Okay, so on this one here, we're going to go with, once you see this real quick, we're going to come out here and think of this in spreadsheets. Here's the answer, I guess the idea. You want to go put it in the form of y equals mx plus b. So yeah, list in spreadsheet is going to be awesome. So we're going to get 2 points. We're going to go with, Noah says -2, 3. Perfect. And then we'll pick another point. What's another good point, guys? Two and 9. I think that looks good too. So 2 and 9. So we're going to turn on the calculator, work with these 2 points, put them in there, and then we're going to go ahead and get the M and the B from this in the spreadsheet. After that, we'll come back here and plug it in. So turn this on. Okay, so here we're going to go with -2 and 3, and then 2 and 9. Come back over here, menu, 4, 1, 3, and then B, control this madness, enter, enter. We're going to go 1.5 and 6, so I know, just in case you didn't know this, change this one to a fraction. 3 out of 2, okay. Well, just to change this into a fraction, pay attention to this, look at this one. We're going to copy this one, we're going to come here, Control C, I'm going to Control add a document over here, go to calculator, Control V to paste it, then we're going to go to menu, we're going to go to the number, change it to a fraction, enter, so it's 3 halves. So we're going to go with 3 halves right here, we drag down right there, and I believe 6 goes right there. So 3 halves, x plus 6. Okay, thank you, Noah. I was asking him real quick, what do you think of here? He says a squared plus b squared equals c squared. Perfect. The one across has to be your c. These two can be a or b, either or. So I'll go with the small one to be a, this one will be b, and the formula will be a squared plus b squared equals c squared. So we're going to say a squared plus b squared equals c squared. Again, the longest side is across, the diagonal in this situation. So we're going to come out here and put these numbers here. 8 squared plus 15 squared equals c squared. And then, okay, and then C really is TQ squared, so it has to be this one. I think it's this one right here, guys. What do you think? Yes, sir. So this one here is basically setting up, and the ratio is basically this ratio is equal to this ratio, making it a proportion. Now, the way these are set up is sky's the limit. You can choose however you want. I'm going to start at 15 and say that one goes to 22.5. As, I can pick any other side here, and I'll say as 20 goes to 30. Has to be consistent like that. That is a good example. One that is not a good example was say I went 15 to 25, or 7 to 22, and then I can come back over here and say 30 to 20. It just doesn't work out. I have to go in the same direction from corresponding sides to corresponding sides. So let's come out here and pick out the first one, see what's going on here. This says y goes to 15, and where's y? Y goes to 15. That works. That's fine. That's the way they want to compare it. But we would have to have over here 28 going to 22.5. And here it says y goes to 15 as the other way. It's having it go the other way. Wrong. It has to be in the same direction, same mirror image, same mirror arrows. Y goes to 28. That's fine. They want to compare like that. So we need another arrow from this figure going this way. As 5 goes to the same corresponding side here. It should go over here, but it's not. It's going here, which is still wrong. Okay, it should go over here. It really should go over here. So that makes that wrong. So the next one is saying 20 goes to 30. Let me get this out of the way. 20 goes to 30. As 5 goes to x. As 5 goes to x. Perfect. Corresponding side. Corresponding side. Start on this figure. And on this figure for both of them. It works out. Perfect. Let's check the next one. 15 to 20. Or 15. Okay, 15 goes to 20 as what should be 22 going to 30. as x squared minus 30. No, it just kind of changes up here. So no, that one's wrong also. Final answer is C. This is pretty easy. A diagram, or sorry, that diagram shows a cone and its dimensions. Here's a cone. Which measurement is closest to the volume? How do you get the volume of a cone? One-third BH. Big B is your area of the base, which in this situation we're talking about the circle. So how do you get the area of a circle? And area of a circle would be pi radius squared. So your volume is equal to 1/3. This one no longer is B. We're going to change it to pi radius squared times your height. 1/3. Pi is pi. Radius in this situation is 5 squared times your height of 12. And plug away on the calculator and let's see what we get. So I'm going to end all of it this way and go y of volume equals, I'm going to go control. Division 1/3, I'm going to go pi radius squared, I think it's 5 squared, times your height of 12. I'm going to go comma B, enter, 314-ish? Oh yeah. Way to go, Liz. Okay, so that works out good. Let's go to the other one. Next question. So this one here, the table describes two dilations. Dilations mean to, kind of really it means to multiply. So dilation means to multiply. Which row describes this dilation? So this triangle is dilated, multiplied by a scale factor of 1/2. Which one of these shows a multiplication of 1/2? Which one shows multiplication with 1/2? That second one goes there. And then the square is dilated by a scale factor of 2. Which one's showing a scale factor of 2? That is pretty easy. So we're going to come out here, make sure you know. This means to multiply. Okay, so on this one right here, we have the volume of a cylinder is 87.35 cubic inches, and the radius is 5.17 inches. Which equation can be used to find h, the height of the cylinder in inches? So this is different. Basically, you can end solve it, or you can just set it up like the way they did it to solve for it. Sky's the limit how you want to approach it. I'm going to go ahead and do it the way we're supposed to do it. Remember, volume of a cylinder is going to be volume is equal to BH. When you have a cylinder, I'm going to come down here and draw this cylinder idea. You're going to have a base as a circle. So when you talk about the area of the base, that means the area of a circle, which is pi radius squared times your height. So we're going to start plugging in the values that we know. Okay, so in everything, we do know the volume. The volume is going to be 87.35. The radius is going to be 5.17. The height is going to be h. So we don't know what is the height. We know everything else, and we're going to plug that in here. So we're going to go 87.35, which is your volume, is equal to pi. And we're going to go out here and put the radius of 5.17, and then times your h. Now, at this moment, right here, guys, just go back to 7th grade with me on the right-hand side over here. Okay? So I'm going to step off and just come up with a nice, easy number. I'm going to go with 8 is equal to 4x. So look at this. This is like my 8 right here. So on this one, just step back to elementary, 7th grade. This is like 8. These two together, when you multiply them out, imagine it as your 4. And this over here will be your x. So back in 7th grade, how did you figure out to get what x was? What did you do here? What operation did you do here? We would divide by 4, right? And it gives you 1 divided by 4 here. These would cancel out. It's a really sneaky 1 here. This is a 1x, and that's what you always want, the 1x by itself. So on that note, I'm going to divide by whatever is by my variable. The 4 is here by my variable, so I divide by 4. On that note, remember, this is like your x, and this together is like your 4. What do I do to get my x alone? what do I do to get my h alone? So I'm going to rewrite it again. 87.35 equals pi 5.17. Ooh, I forgot to put squared here. No one told me that. I was just checking on y'all guys. Seriously, you got to remind me. Check up on those things. I want to get the h alone, so I'm going to divide by this number. Whatever number it is, pi times 5.17 squared. I have to divide both sides, pi and 5.17 squared. These cancel out, leaving me with h, which is h here. These two are my answer, 87.35 being divided by this other number of 5 times 5.17 squared. This is what your h is equal to. So 87.35 divided by 5.17 squared. Good, but we're missing the pi. Out. Out. This is reversed. This one's upside down. Again, completely upside down. So we're going to have 87.35 on top. Check. Divided by pi. Pi. 517 squared. Perfect. That's the one right there. D is your answer. So on this one here, guys, once you hear of a box, okay, this is a box that's shaped like a square prism. What should you automatically be thinking? You should know this one already. Square root. That's what you should be thinking already. So once you hear of a square like this, and they ask you about the height, the length, the side, basically what you're doing, getting the square root. Okay, that's what you kind of want to do. The box is shaped like a square prism. So I got it wrong in my head. I didn't read it right. Okay, so it's a square here, and that's the height. So from one side, or one square, to the other square, which means there's another square right here. So this note here, we're going to come in here. This is going to be the height, 8 inches. And the area of the square base, this is what you want to hear, square base, square inches. Once you hear this stuff, you have a square of 16. So the question they're going to be asking over here, what is the total surface area? So to get the total surface area, you're going to have the pH plus 2b. And then when it comes to this one here, we need to know the perimeter of the base. The base is saying here, the base has it's a square prism. So the base is a square. All right, it's a square here. We don't know anything about it. We know the prism from base to base is 8. So now it is giving us over here, the square base is the side of a square of 16. So on that note, when you ever hear like a square, you want to kind of automatically start thinking the square root, which gives us 4. So now we know the side of the square is a 4. Now the reason that works out because the side is what? The same as the other side here. When it comes to the square inside the square units, there's 16. So what makes 16 little figures into a perfect square slash get the square root of it, which is a 4. So it's a 4 by 4. So now we know the side length of our square here. We have a 4 by 4 by 8. So now we come back over here. Let's do the surface area formula. This is a square, the base, square's perimeter. So I have to go around the square. I have to go around it like this. And I have to add up all the sides. That's perimeter. So I'm going to go 4. Well, actually, let me go back. We're going to go 2, length plus width, length plus width, 2 of them because we have length and width over here, length plus width, and then h is h plus 2 times, how do you get the area of a square? What length times width? So we're going to come out here and go 2 and start adding up these numbers. 4 plus 4 times the height of 8 plus 2, and then parentheses 4 times 4. So that's basically it right there. Let's come out here and, I guess, turn on the calculator, start doing it. Okay, what is it? 160. Perfect. Thank you, Big Dog Vic. Appreciate that one. Let's do one more, yes? Okay, this one here. Okay, this was a good question. A lot of people got this one wrong. It says polygon A has an area of 27 r squared meters. Polygon A is dilated by a scale factor of 3. Scale factor dilation means to multiply by 3. So we're going to go here, multiply by 3 to create polygon B. What is the area in square meters of polygon B? So remember, square, okay, it's going to be basically the same size, right? For it to be the same size, it's going to be all around equal length with a right angle here. And they're going to ask about the square inside. How many squares on the inside? That's what square in area, and that's what area means, length times width. Both of these multiply together. So that's how many square units on the inside. So it's saying A. This is the way it goes. A was going to be a small thing here. But then they multiplied it by 3. So it's no longer A here. It's A, and A. But if it's going to be dilated and area, it's talking about this length and this length. So now I have 3A's this way and 3A's this way, and this is filled in with other A's. Well, that's going to create B. So B basically is now all of this together. Well, how many A's make up the B? What's that way? How many A's make up the B? 1, 2, 3, 4, 5, 6, 7, 8, 9. Because of this one here, we're going to have 3, right? Times an area. I'll go. I don't know. We're going to go this one here. What's it called? Well, basically the A, when it gets blown up, dilated, now it's going to be how many A's? 9 A's. So that is going to be right. This is really basically your B. So let me explain to you mathematically with numbers and everything now. So if you have an area of A, and you're going to go ahead and make it how much bigger? Well, dilated, right? Let's get the area. We're going to go right A, and we have length times width, which is this length times this width, and we're going to make it 3 times bigger. Well, they're basically going 3 lengths and 3 widths. You see that? So area now for the new one, prime, would be what? When we should do math, pull those things out, which is 3 times 3, or I should write it again, 3 times 3. And then put the length and the width times length and width. So the A prime, which would basically be 9 times length times width, which the area of the original thing was really area length times width. So now it becomes that. Okay? So that's how we get this idea. So let's come out here. We're going to basically get A, right? And we're going to multiply it times how much? 9 to give me the new A prime slash B. So we're going to go with 27R times 9. Well, geez, how do we do this one? Well, basic multiplication, I should write it the old school way, times 9. We're going to multiply number with number. So it's 9 times 27. And you know what 9 times 27 is? What is 9 times 7? 63. 24, 3, 18, 19, 20, 21, 22. And then don't forget the R. So 243 R's. Sorry, I forgot to start recording. 5%. Yes, everything like that. 1 plus 2.5%. So at the end of the first year, okay, so at the end of the first year, let's do this right here. So put that in the calculator, and what did you get here? On the inside of the harmony? You got it? Press enter, man. This is what I need. Yes. Yeah. Comma A, whatever you put. So on this one right here, it gives you A is equal to 10,250, but it's asking only the interest. So I'm actually going to come out here and subtract the 10,000. It's going to be 250 for the the account earning at the end of the first year, and it would have 250 in the first year. At the end of the second year, so basically going to do it again. We're going to go 1, 2, 3, 10,000 here. 1 plus 2.5% again, and we're going to go 2 now. And that's going to give us a equals 10,506.3. But again, it's only asking the interest. How much interest is? Oh shoot! The second one says at the end of the second year, how much would they have in total? So this is my answer for the total right here. At the end of the second year, the account will have earned a total bank. Oh, of interest again, my bad. So then we're going to come out here and subtract that 10,000. 506. 506.3. Oh, it's 506.25. I think this must be rounding for me. Yeah, 0.25. Perfect. Okay, since we're almost done, let's go to the next one. Just finish it up. Susan Jerry paid that much for 6 oranges. How much is each orange? So that means divide by oranges, guys. Divide by 6, which is the number of oranges, which gives you how much? 42? Which gives you 0.42. And that means each, every, per. So the equation will be y equals 0.42x. That's your answer. On that note, that one goes there. Hey, thanks, Noah. Thanks, Vic. Way to go, big dog. And Kai. Thank you, Kai. Kai means ocean.